Good morning. Myself Dr. A. Vadivel. Currently I am working as an assistant professor in the Department of Mechanical Engineering, C. Ramakrishna Engineering College, Coimbatore. Now I am going to handle the topic on internal combustion engine. Okay, let's start about that internal combustion engine. So what is meant by internal combustion engine? So internal combustion engine is an engine in which the combustion of fuel oxidizer mixture occurs inside the combustion chamber. In internal combustion engine we are using that fossil fuels like petrol and then diesel for burning purpose, and the burning of fossil fuels we are converting, like chemical energy of a fuel is converted into heat energy at first inside the combustion chamber, and after that we are converting that the heat energy produced by burning of fuel is converted into mechanical energy, is called as rotational power. So this generally happen inside the internal combustion engine, and this rotational power, like this mechanical energy, is we are using for transportation purpose like automobile and then power generation unit. Even power generation like electricity production purpose also we are using that internal combustion engine like diesel genset. And application. So what is the applications of internal combustion engine? Generally internal combustion engines we are using that like automobile and then railway transportation purpose, power generation side, chips, transportation of chips, aviation, and then garden applications also. Next, classification of internal combustion engines. Now we are going to discuss about that general classification of internal combustion engine. So now at first, according to the type of fuel we are using. So normally in internal combustion engine we are using that petrol and then diesel as a fossil fuels we are using to produce that power. So the first category is according to the type of fuel, like first subdivision is petrol engine, second one is diesel engine. Then second category is according to the method of ignition, like first one is spark ignition engines, we are using that spark ignition method in petrol engine and compression ignition method in diesel engine. This is the second category. And third category according to the number of strokes. So normally we are using that 2-stroke and then 4-stroke engine both in petrol and then diesel mode of fuel. So in 2-stroke engine, like we are developing that 2 strokes for 1 revolution, and in 4-stroke engines we are producing 4-stroke to complete that entire process within 2 revolution of crankshaft. And fourth category is according to the cycle of operation. So here we are developing like 3 different cycles. First one is Otto cycle. So basically Otto cycles is followed by that petrol engine, and second one is diesel cycle. So diesel cycle is followed by the diesel engine, and third one is dual cycle, is a combination of Otto and then diesel cycle. And fifth category according to the speed of engine. So normally we are using that slow speed, medium speed, and then high speed application based on that application where we are using that internal combustion engines. And sixth category according to the cooling system. So generally in internal combustion engine at the time of combustion process almost 750 degrees Celsius were developed inside that internal combustion engine. So it's our main aim to avoid that overheating of engine. So we are using that cooling system. So we are framed inside that internal combustion engine to avoid overheating of an engine. So in this category we are using that 2 different type of cooling system. So first one is air cooling system and another one is water cooling system. And the 7th category according to the method of fuel injection. There is a 2 different type of injections we are followed. One is carburetor engine type and second one is air injection type. And that 8th category according to the number of cylinders. So normally we are using that single cylinder, 2-cylinder, 3-cylinder, even in a 4-wheeler we are using up to 6 cylinders engines we are using to propel that power. Right. So next we are discussing about that what are the internal parts of internal combustion engine. So in this slide we are seeing that like general automobile engine, like this is the multi-cylinder engine. In this figure we seen that there is a lot of parts. Okay. So there are the variety of parts we are using in internal combustion engine for performing that entire process. Out of this, the main important parts of an internal combustion engine. So first one is cylinder. So what is meant by cylinder? So the entire parts of an internal combustion engine were assembled in this cylinder only. So it is a closed assembling one object like cylinder. So next one is piston. So piston is a reciprocating device. Inside the cylinder the piston will reciprocate up and down. And second one is connecting rod. So and third one is crankshaft. The purpose of connecting rod is to connect the piston and then crankshaft. And the crankshaft, the third important parts of internal combustion engine is crankshaft. So the crankshaft is in rotational motion inside that inside that cylinder. So the fourth one is camshaft, inlet manifold, exhaust manifold, spark plug, fuel injector, cylinder head, combustion chamber. So these are all the main parts of an internal combustion engine. Okay. So next one is IC engine terminology. What is meant by IC engine terminology? So generally inside that internal combustion engine the piston will reciprocate the piston will reciprocate inside that internal combustion engine with up and down motion. So what is the extreme limit of piston reciprocating area inside that combustion chamber? So one is DDC, that is called as top dead center, and another one is BDC, that is bottom dead center. So in between DDC and BDC only the piston will reciprocate inside the combustion chamber, and the piston reciprocating this area, it is called as stroke, S-T-R-O-K-E, stroke. Generally it is called as piston reciprocating area. Then next one is bore. What is meant by bore? B-O-R-E. Bore means it is the diameter of a cylinder. So generally the piston diameter, it is called as bore. So L means stroke, D means bore, like. So next one is stroke volume or displacement volume or cylinder volume. What is the meaning that? So the entire volume the piston will reciprocate inside the cylinder. The entire volume occupied by that piston reciprocating area, that is called as displacement volume or cylinder volume. Generally it is called as area into length, the stroke, by 4 d square and then L. So the total volume, how we calculate the total volume of an cylinder? So generally the total volume of cylinder is calculated by summation of displacement volume and then clearance volume. So what is meant by clearance volume? Okay, so the clearance volume, it is a very minute area above the displacement volume. Okay, so in the place of clearance volume only the entire combustion will takes place. The entire combustion of fuel, fossil fuel, whether petrol or diesel, will happen only in clearance volume. Okay, it's a very minute area, so that is called as clearance volume. The meaning of clearance volume is it's a area where the combustion of fuel will takes place during the power stroke of an engine. So the total volume of engine is calculated by summation of displacement volume and then clearance volume. So finally we discuss about that compression ratio. What is the meaning of compression ratio of an internal combustion engine? So generally the compression ratio of an engine is calculated by, it is the ratio of total volume of an engine divided by clearance volume of an engine. So total volume is Vc plus Vs, like it is a summation of combustion clearance volume and then displacement volume divided by clearance volume. So in petrol engine generally the compression ratio is less than 10. We are maintaining that the compression ratio is less than 10. For in the case of diesel engines we are maintaining that compression ratio is above 10. Like. So now we are going to discuss about that how the 4-stroke diesel engine is working. Okay, so now we are discussing about that how this 4-stroke diesel engine is working, and after that 4-stroke petrol engine, and after that 2-stroke diesel and then 2-stroke petrol engine, how this 2-stroke and then 2-stroke petrol and then 2-stroke diesel engines are working. And finally we will discuss about that what are the comparison between 2-stroke and then 4-stroke engine. After that finally we discuss about that, we will discuss about that what are the comparison between spark ignition engine like petrol engine and then compression ignition engine like diesel engine. So now we are going to discuss about that 4-stroke diesel engine. How this 4-stroke diesel engine is working, right? So before we are discussing about that working of 4-stroke diesel engine, so first we discuss about that what are the internal parts of an 4-stroke diesel engine. So here I mentioned about that in this figure, I mentioned about that, like generally inside that internal combustion engine, the main parts of internal combustion engine is, first one is piston, and second one is connecting rod, and third one is crankshaft, and fourth one is inlet and then exhaust valve, and fifth one is fuel injection device, like whether spark plug or fuel injector. So generally in diesel engines we are using fuel injector instead of spark plug. So the spark plugs we are using in petrol engine only. In diesel engine we are using fuel injector, right? Yeah, so these are the 4-stroke different stroke of diesel engines. So first stroke is suction stroke, and second stroke is compression, and third stroke is power stroke, and the fourth, that last stroke is exhaust stroke. So now we are step by step discuss about that what are the process that had happened in each stroke. So we are starting from suction stroke. Now we are starting from suction stroke. What is meant by suction stroke? So during the suction stroke, the fresh air is injected or sucked inside the cylinder from the atmosphere. So during that suction stroke, initially the piston will start to reciprocate from top dead center to bottom dead center towards downward direction. So what happened? So during that piston will reciprocate from DDC to PDC. So particular vacuum is created inside that cylinder of an internal combustion engine. So based on that vacuum created inside that internal combustion engine, so automatically the fresh air will suck inside the cylinder from that atmosphere. So at the end of suction stroke, the piston will reach bottom dead center, and the entire volume of an cylinder is occupied by the fresh air. So generally it's happened during the suction stroke, right? Then we move to that compression stroke. What happened in that compression stroke? So in the second stroke, like compression stroke, the piston will place in that bottom dead center initially. At that time both the inlet valve and then exhaust valve are closed. Okay, so this is a very important thing. During compression stroke of 4-stroke diesel engine, both inlet and then exhaust valve is closed. So at that time the piston will start to reciprocate from BDC to DDC, like bottom dead center to top dead center. So during this combustion process, the entire volume of air, fresh air occupied inside the cylinder were compressed at very high pressure and very high temperature at the end of compression stroke. Normally at the end of compression stroke, the volume, the volume of air occupied inside that cylinder, that air pressure will reach almost 40 bar. Okay, so it is a very high pressure. So 40 bar pressure is maintained at the end of compression stroke. Now we move to that power stroke. It's a third stroke. It's a very important stroke. During the power stroke, via fuel injector, it's very important thing. Via fuel injector, we are injecting that diesel fuel inside the combustion chamber with a fine spray. Okay, it's a fine spray. So what's happened? So already at the end of combustion stroke, the high pressurized air is occupied inside the cylinder, so it will ready to burn. Okay, so at that time we are injecting diesel with the fine spray inside the combustion chamber. What's happened? So immediately the diesel will vaporized, because already the high pressurized, high temperaturized air is maintained or occupied inside the cylinder. So immediately the fuel, the diesel fuel is vaporized. Okay, so the burning will happen inside the inside the cylinder during the power stroke. So at the time of power stroke, both inlet valve and then exhaust valve remains closed. Okay, so what's happened? So once the heat jet will develop during the power stroke, what's happened that this heat jet will push the piston at very high speed. Okay, so the piston will reciprocate from DDC to BDC at very high speed. Generally it is called as power stroke or expansion stroke. Okay, so what happened? At the end of power stroke, the piston will reach the BDC, I mean bottom dead center, at very high speed. Based on that, combustion will take place inside the cylinder, right? Okay. Now we are going to that last stroke, that is called as exhaust stroke. What happened during that exhaust stroke? Okay. So during that exhaust stroke, the exhaust valve is open. Now only, I mean that during that exhaust stroke only, the exhaust valve is open. Unless otherwise, the exhaust valve remains closed in all three strokes, like starting from suction stroke, combustion stroke, and then power stroke. The exhaust valve will remains open only in exhaust stroke. Okay, so during that exhaust stroke, the exhaust valve is open. Next, the piston will start to move from BDC to DDC. What's happened? So at the end of power stroke, the entire fuel is burned. Finally, the smoke, I mean that the entire fuel is burned means finally what happened? The smoke is occupied the entire cylinder. So that during that last stroke, the entire volume of smoke will come out from that cylinder, because the piston will reciprocate from bottom dead center to top dead center. So at that time the exhaust valve is open, so the smoke will come out from that cylinder. So finally the entire process will complete. Okay. So the first stroke is a suction stroke. During that suction stroke, the fresh air only will injected into that cylinder. And second stroke is a combustion stroke. During combustion stroke, the fresh air is compressed at very high pressure, like 45 bar and then high temperature. And during that power stroke, the burning of compressed air will happen via fuel injector. We are supplying that fuel like diesel as a fuel. So during that power stroke, almost 65 bar pressure is developed, okay, and also the huge amount of heat jet is produced during that power stroke. That heat jet only push the piston at very high speed to the downward direction. I mean the piston will start to reciprocate at very high speed towards that bottom dead center. And the last stroke is exhaust stroke. So during that exhaust stroke, the entire smoke occupied inside the cylinder will come out from that cylinder. Okay, so the entire process will is over. Again the suction process will start. So it is a cyclic process. So once the 4 strokes is completed, the entire power will reach into that wheel, automobile. Okay, so then only the wheel will start to move at very or will circulate or rotate at very high speed. So whenever the power stroke is happen, the entire power is converted or move to reach that wheel. So then only the automobile will start to move at very high speed, slow speed to high speed. So this is a cyclic process. Again and again this power stroke is happen. Okay, so this is the 4th stroke. I mean that during that entire 4th stroke, the piston will reciprocate 2 times. What is meant by reciprocate? Reciprocate means there is a 2 strokes is there. 1 revolution means there is 2 stroke, is correct. So the piston will start to from DDC to BDC, that is 1 stroke, and BDC to DDC, second stroke. If suppose the piston will complete 2 stroke, 1 revolution of crankshaft is over, is correct. The crankshaft will rotate 1 time, 360 degree. So the first 2 strokes, the piston, I mean that the crankshaft will complete that 1 revolution, I mean 360 degree, 180 plus 180. The next power stroke and then exhaust stroke, again the 2 stroke is happened that during this power and then exhaust stroke, the piston will complete another 1 revolution like 360. So 360 plus 360, 720 degree is completed, then only it is called as 2 revolution. So 4 stroke is happened that in 2 revolution of crankshaft. So then only it is called as 2 stroke diesel engine. Okay, right. So this is the PV diagram of a 4 stroke diesel engine, like P means pressure, V means volume. So we are drawn this one graph in between that pressure and then volume. We are maintaining volume as x axis and then pressure is y axis. So first thing, during that suction stroke, what happened during this suction stroke? So during this suction stroke, the piston will start to move from DDC to BDC. So definitely the volume will increase. So inside that cylinder, the volume is increased. So the volume is increased. At the same time, what about the pressure inside that cylinder? So generally during that suction stroke there is no such much difference in pressure of a cylinder inside the cylinder. So almost the pressure is maintained at constant, okay, like atmospheric pressure like 1.032 bar is maintained inside the cylinder. The first stroke, during that first stroke like suction stroke, the volume will increase from Vc to V1 and pressure is maintained almost constant. Then second stroke, yeah, so the second stroke is compression stroke. During compression stroke, the piston will reciprocate from VDC to DDC, so the volume of a cylinder slowly it will decrease, okay. The volume occupied by an air inside the cylinder is gradually decrease. So what's happened? The pressure is increasing during compression stroke from 1 to 2, the pressure it will increase. At the same time, the volume of air occupied inside the cylinder is decreasing. So what's happened? At the end of compression stroke, the pressure will build up at very high pressure like 45 bar and the volume is kept closer, right? Okay. So at the end of compression process, the P2 pressure is almost 45 bar. Then next is the third stroke is like power stroke, that is called as heat supply process. During that power stroke, we are maintaining the pressure is maintained at constant during that like in diesel engine. In petrol engine, volume is kept at constant during that power stroke, but in case of diesel engine, we are maintaining pressure is constant in that power stroke. So what happens? So during that power stroke, we are supplying that adequate amount of fuel to the cylinder. So the fuel, I mean the diesel will mix with high pressurized air. Immediately the diesel will start to evaporate and then one stage it will burn, okay. So during that power stroke, the huge amount of heat is produced, I mean that heat jet is produced inside that combustion chamber. Then this process is called as power stroke. During the power stroke, the pressure is maintained at constant in diesel engine. Next stroke is, I mean what's happened next? So the 3 to 4 is the expansion process. During that expansion process, I mean that after burning of fuel, what happened? The heat jet will push the piston at very high speed towards downward direction. So the piston will start to move at very high speed from DDC to BDC. So what's happened? The volume is increasing inside the cylinder. At the same time, the pressure will down. Okay. So at the end of our stroke, the piston will reach BDC. And the last stroke is again exhaust stroke. So during that exhaust stroke, again that pressure is maintained at constant, almost constant. Only the smoke will come out from that cylinder. So there is no much difference in volume, I mean there is no much difference in pressure inside the cylinder during exhaust stroke. Only the volume it will decrease because the piston will start to move from BDC to DDC. So the entire volume will reach almost clearance volume. Right. So this is the PV diagram of 4-stroke diesel engine. As of now, we are completing the working of 4-stroke diesel engine. How this diesel engine is working, in each strokes what happens. So we are detailedly discussing about that 4-stroke diesel engine. Right. Now we are moving to from 4-stroke diesel engine to 4-stroke petrol engine. So before we start to discuss about the working of 4-stroke petrol engine, so first we discuss about that what is the main difference between petrol engine and diesel engine. I mean that 4-stroke petrol engine and 4-stroke diesel engine. There is no much difference between petrol and diesel. In diesel engine we are using that fuel injector. Instead of fuel injector we are using spark plug in petrol engine. Only the difference is fuel injector we are using in diesel engine. Spark plug we are using in petrol engine, only the difference, okay. So only one difference, rest of them almost same, right. So now we are going to discuss about that working of 4-stroke petrol engine step by step, okay. So here also there is 4 strokes is maintained, the same strokes also always maintained here also. First stroke is suction stroke or inlet stroke, second stroke is compression, and third stroke is power stroke, and last one is exhaust. What happened in that suction stroke or inlet stroke? Okay. In diesel engine, what happened during that suction stroke? In diesel engine, the fresh atmospheric air will injected into that cylinder or sucked into that cylinder from atmosphere, is correct? Okay. But in petrol engine, there is slight changes. In petrol engine, both petrol and then air are mixed outside the cylinder, the device it is called as carburetor. We are using carburetor in two-stroke engine like in two-wheelers, right? Carburetor. The purpose of carburetor is to mix the adequate amount of or adequate mixture of air and then fuel. That is the purpose of carburetor, that is called as stoichiometric mixer. The technical name it is called as stoichiometric mixture. So normally the carburetor is kept outside the cylinder, not inside the cylinder. The purpose of carburetor is to mix the air and then fuel. So here air and then fuel is petrol. So the petrol and then air is mixed with the adequate amount with the proper percentage like 50-50 or 40-60 or 20-80, and after that the fresh air and then fuel like petrol will enter into that cylinder during suction stroke. But in diesel engine case only air is enter into that cylinder, right? That is the second difference between petrol and then diesel engine. Okay, so next during that suction stroke what's happened, the piston will start to move from DDC to BDC like top dead center to bottom dead center. So during that suction stroke the fresh air and then petrol will enter into that cylinder. At the end of suction stroke the inlet valve is closed. Okay, at the starting of suction stroke the inlet valve is open, the fresh air and then petrol will enter into that cylinder and occupy the entire cylinder. Okay, entire volume of a cylinder. At the end of suction stroke the inlet valve is closed. What is the next stroke? The next stroke is compression stroke. What happened in 4-stroke petrol engine? During compression stroke the fresh air fuel mixture, I mean the fresh air and then petrol is compressed at very high pressure and high temperature during that compression stroke. During that compression stroke the piston will start move from bottom dead center to top dead center, right? So at the end of compression stroke the piston will reach top dead center, right? So during that compression stroke both inlet valve and then exhaust valve is closed, that is very important. So there is no possibility to escape that air fuel mixer outside from that cylinder, is correct? So once that both inlet valve and then exhaust valve is closed, there is no possibility to escape that air fuel mixer outside the cylinder. So what's happened? The entire air and then petrol will compressed at very high pressure and then high temperature. Here also the pressure of air fuel mixer is almost 50 bar, right? So at the end of compression stroke the air and then fuel is compressed at a very high pressure and then high temperature. At that time the next stroke is power stroke. The third stroke is power stroke. So during that power stroke what happened? Okay, so during that power stroke of an 4-stroke petrol engine we are using spark plug. Okay, at the head of cylinder, I mean at the portion of cylinder head we are providing spark plug instead of fuel injector. In diesel engine we are using the fuel injector, but in the case of petrol engine we are using spark plug. Okay, so we are using external battery like 48 volt or 12 volt battery we are using outside the cylinder like in automobile. By using that battery we are giving that small power supply to that spark plug, I mean that electricity. Okay, so we are providing that power like electricity to the spark plug. What's happened? So at the time of power stroke when small spark is induced by the spark plug inside the cylinder, what's happened? So once the spark is induced via spark plug inside the cylinder, already air and then petrol will compress at very high pressure and then high temperature and maintain inside the cylinder. Okay, so what's happened? So once the spark is induced, immediately the entire air and then fuel will bond inside that cylinder. Definitely it's happened that. Okay, so same scenario will happen during that power stroke in diesel engine, but the case is in diesel engine only air is compressed at very high pressure and then temperature, but in case of petrol engine both air and then petrol will compressed because petrol have that very low self ignition temperature, but the diesel will have that very high self ignition temperature. So that is the difference, main difference between why we are supplying only air in diesel engine, why we are supplying air and then petrol mixer inside the cylinder in petrol engine. That is the main difference, because petrol having that very low self ignition temperature, but diesel having that very high self ignition temperature, right? So right, come to the point, during the power stroke the burning will start once the spark will induced to the cylinder via spark plug, right. So, the huge amount of heat is developed during that power stroke. That heat jet will push the piston at very high speed during that power stroke. The piston will start to move very high speed from DDC to BDC. So, then only it is called as power stroke. Okay. This high speed of rotation, I mean the high speed of transportation of piston from DDC to BDC, that convert that like reciprocating motion into rotary motion in crankshaft at very high speed. So, once that crankshaft will start to rotate at very high speed, the crankshaft is directly connected to that wheel via gearing mechanism. So, what happen? So, once the crankshaft will start to rotate at very high speed, automatically the wheel, the power will received to that wheel, again that wheel also will start to move at very high speed. Then only the automobile will start to move from low speed to high speed. That is happen during that power stroke. Okay. So, what is happening in that exhaust stroke? It is a final stroke for that 4-stroke petrol engine, right. So, during that exhaust stroke, already we discussed in diesel engine, the same scenarios happened in petrol engine also. What's happened? So, during that exhaust stroke, the exhaust valve is open. During that exhaust stroke only the exhaust valve is open. So, once that exhaust valve is open, at the same time the piston will start to move from bottom dead center to top dead center. What's happened? So, the entire volume of smoke occupied inside the cylinder will come out from that cylinder. Okay. So, that happened during that exhaust stroke. Okay. So, again the cycle will complete, so I mean that recycling, and then continue that starting from suction stroke, compression stroke, power stroke, and then exhaust stroke. So, that happened during that 4-stroke petrol engine. That is the general working principle of 4-stroke petrol engine. So, as of now we are completing 4-stroke diesel and then 4-stroke petrol engine. At the conclusion, that what is the main difference between working of 4-stroke petrol and then 4-stroke diesel engine? Only that there is a two difference is there. The first difference is in diesel engine we are using fuel injector, and in petrol engine we are using spark plug. That is the first difference. And second difference, during that suction stroke in diesel engine we are supplying only fresh air into that cylinder, but in petrol engine case we are using that, we are supplying air and then petrol mixer into that cylinder. That is the second important difference between 4-stroke petrol and then 4-stroke diesel engine. Unless otherwise again rest of thing like in each process, the same process is happen in entire 4 strokes like suction stroke, compression stroke, power stroke, and then exhaust stroke. So, during suction stroke the fresh air and then or air and fuel mixer will enter into the cylinder or occupy the cylinder. During the combustion stroke, both the engine, the fuel or fuel air mixture is compressed at very high pressure and temperature, and during the power stroke both the engine, the burning of fuel and then air is happen whether the fuel injector or spark plug, and during that exhaust stroke only that thing is the smoke will come out from that cylinder, both the engine like petrol engine and diesel engine. So, that is the simple working principle of 4-stroke petrol and then 4-stroke diesel engine, right. Okay. So, this is the PV diagram of 4-stroke petrol engine like pressure and then volume. So, we are plot the graph between that pressure and then volume. The same scenario is happen in that 4-stroke petrol engine also. The only the difference is here we seen that one graph between that pressure and then volume. The first stroke is suction stroke. During that suction stroke there is no much difference in pressure, only that volume will increase from clearance volume to V1, and next stroke is compression stroke. During that compression stroke, so definitely the volume of an air and then fuel mixer occupied inside the cylinder it will decrease. So, at the end of compression stroke we are supplying that spark, one small amount of spark via spark plug inside the cylinder. So, during that combustion process combustion will start at constant volume. So, during petrol engine the power stroke is happen that or that heat supply process will happen at kept at volume is constant, but in diesel engine the pressure is maintained at constant. That is the main difference between petrol engine and diesel engine. For the diesel engine case we are maintaining pressure is constant at the time of burning of fuel, but in case of petrol engine we are maintaining volume is maintaining is constant during that burning of fuel, right. So next, during that power stroke, the piston will start to move from DDC to BDC. So the volume it will increase, at the same time the pressure will decrease. Okay. So during heat supply and then heat releasing, both the process we are maintaining volume is constant, but in case of diesel engine we are maintaining heat supplied process only, we are maintaining pressure is at constant, maintaining at constant. But during that 4-stroke petrol engine, we are maintaining volume is constant, both the heat supply and then heat releasing process. And finally, during that exhaust process, we are again that pressure, there is no much difference in pressure, only that volume it will decrease, because that the piston will start to move from BDC to DDC. So that is the PV diagram of 4-stroke petrol engine. Right. So as of now, we are completing 4-stroke engine, both the case like petrol engine and then diesel engine. Now we are moved to that 2-stroke diesel engine. Okay. So what's difference between 2-stroke and then 4-stroke engine, right? So before we start to discuss about the working of 2-stroke engine, so first we discussed about what is the main difference between 2-stroke and then 4-stroke engine, right? In 4-stroke, each process taken that each stroke, I mean that each stroke one process is over, like during that suction, first stroke suction process is completed, second stroke compression, third stroke power, and fourth stroke is exhaust. So each stroke is taken that one stroke is taken that, I mean during that each stroke one process is completed, is correct. So 4 process 4 stroke. But in case of 2-stroke engine, in each stroke 2 process at a time 2 process is happened that. So that is the main difference between 2-stroke and then 4-stroke engine. So which one is quick operation? So which one is quick process? Definitely 2-stroke, because 4 process, but it will take only 2 strokes. Okay. So whether the piston will start to from DDC to BDC and BDC to DDC. So only 2 stroke is enough to complete that entire flow process, like suction, compression, power, and then exhaust. So based on this scenario, we conclude that which engine is a quick engine, whether 2-stroke or 4-stroke. Definitely 2-stroke engine is a quick operation as compared to 4-stroke engine, right? Is correct, because in 2-stroke engine at a time 2 process is happened or continued in each stroke. Okay. So that is the simple layout of 2-stroke engine. Like this one is 2-stroke diesel engine. How we are mentioning that this one is diesel engine? Because we are using injector. Okay. So where that injector is using, definitely that engine it is called as diesel engine, not petrol engine. If suppose the spark plug we are using now, definitely that engine it is called as petrol engine. Okay. So this is the general layout of 2-stroke engine. That is the new components will add on inside this engine as compared to 4-stroke engine. In 2-stroke engine, we are focusing about that first thing, cylinder. So it's a closed cylinder. So inside this cylinder, as usual, piston, connecting rod, and then crankshaft. And in 4-stroke engine, we are using valve, like inlet valve and then exhaust valve, in the case of 4-stroke engine. But in this case of 2-stroke engine, instead of valve, we are using port, P-O-R-T, port. Okay. There is 3 different type of ports is there. One is inlet port, via inlet port only whether the fresh air or air fuel mixer will enter into that cylinder, inlet port. And transfer port means the fresh air and then fuel will enter into the combustion chamber via transfer port. And the third port it is called as exhaust port. So via exhaust port only the burned fuel or burned air fuel mixer will come out from the cylinder. So there is a 3 ports we are fitted inside that cylinder. First one is inlet port, second one is transfer port, and third one is exhaust port. Okay. So rest of thing all are same, like piston, connecting rod, crankshaft, all are same as we are using in 4-stroke engine. Okay. Right. So now, so next we are discussing about that working of 2-stroke diesel engine. So what happened in 2-stroke diesel engine? the first stroke is starting from that first stroke, the piston will start to move from bottom dead center to top dead center. During that first stroke, below the piston, the fresh air will enter into that cylinder. Okay. At the same time, in above the piston, the air is compressed. So, suction and compression will happen in same stroke. Okay. So, first stroke is during that first stroke, the piston will start to move from BDC to DDC. During that first stroke, below the piston, suction process is happen, fresh air will enter into the cylinder, and above the piston, air is compressed. So, both suction and then compression at a time it happen during that first stroke. And second stroke, the piston will start to move from top dead center to bottom dead center. At a time, the exhaust port is open and transfer port is also open. So, during that second stroke, above the piston, the exhaust and then power stroke is happened, and fresh air is entered via transfer port to the combustion chamber. So, this is the two-stroke diesel engine working, and next one is two-stroke petrol engine. The same process is happened in two-stroke petrol engine. Instead of fuel injector, we are using spark plug. The only difference between the two-stroke diesel and then two-stroke petrol engine is we are using fuel injector in diesel engine, and in the case of petrol engine we are using spark plug. That is the only difference between two-stroke petrol and then two-stroke diesel engine. Rest of thing all are same. So, this is the step by step process. In again that the first stroke, the piston will start to from BDC to DDC. The suction process is happen below piston, and then compression process happen above the piston. And during the second stroke, below the piston above the piston, both power and then exhaust process is happen. At the time of second stroke, both exhaust port and then transfer port is open. That's all. Okay. So, finally, we conclude the comparison between a spark ignition engine and then compression ignition like petrol and then diesel engine. The first case is, for that case of petrol engine we are using Otto cycle, and in that case of diesel engine we are using diesel cycle, and then fuel we are using petrol. And in the case of compression ignition engine we are using diesel as a fuel, and petrol is a high self ignition temperature, and then diesel has the low self ignition temperature. And introduction of fuel, we are mixing of air and then petrol in the case of spark ignition engine. In compression ignition engine only we are air is injected into the cylinder, only the fuel is injected during the power stroke only via fuel injector. And then fuel ignition we are using spark plug for spark ignition, and then fuel injector we are need that for that compression ignition engine. And compression ratio we already discussed that we are maintaining less than 10 for spark ignition, we are maintaining greater than 10, I mean the 16 to 20 for that combustion ignition engine. And based on that brake thermal efficiency, spark ignition engine like petrol engine have a low efficiency, and then diesel engine produce that higher efficiency. And then weight aspects also, petrol engine is a lighter weight, and then compression ignition engine having the heavier weight due to that inlet and then exhaust manifolds. And the next one is comparison of two-stroke and then four-stroke engine. Like two-stroke, we already discussed that during the two-stroke engine, the four process will complete in two-stroke. The piston will take only one revolution of that crankshaft. The crankshaft will take that only one revolution to complete that entire four process. But in four-stroke engine, the crankshaft will take that two revolution, so to complete that four process. So, quick operation is the two-stroke engine is the quick operation, and then four-stroke as compared to four-stroke engines. And then generally that two-stroke engines needed that greater cooling and then lubrication, because it is a very high speed as compared to four-stroke engine, and four-stroke engine is requirement of cooling and then lubrication is very lesser. And then in two-stroke engine there is no valves, only ports we are using, but in four-stroke engine we are using valves and then actuating mechanisms we are using that. So, it is bulky, and the two-stroke engines is the lightweight as compared to four-stroke engine. So, I really thank that entire management, principal sir, and then head of the department mechanical engineering for giving such a wonderful opportunity for me to give this lecture on internal combustion engine. Thank you.